All right, now we're talking about types of circuits. So we have three different types. There is the series circuit, parallel, and a short circuit. In a series circuit, you notice that when electrons flow out of the battery, it only has one pathway to flow through, meaning that the rate at which electrons are flowing here is the same at which they're flowing here and there, everywhere through the circuit, they're exactly the same. So in these ones, I, or your current, is the same in all resistors. And you can think about it kind of like a hose. If electrons are the water, if the water rate is flowing some rate here, it has to be the same there if there's only one pathway to flow through. If that wasn't true, then the hose would be expanding and contracting, and it doesn't do that. Next, in a parallel circuit, you'll notice there are multiple different parallel pathways. That's why they call it a parallel circuit. Now, in this one, the amount of electrons flowing in here splits up among the three. So the current is not the same in each pathway. However, one thing that is true, the amount of energy that's here has to be the same amount of energy. No matter what pathway you take, you should end up at the same amount of energy when you get there. Meaning that the potential difference from one side to the other in all of these pathways, when I get from this point to this point, no matter which way I go, it's going to be the same amount of energy change. Therefore, your delta V is the same across all resistors. And notice I said across for this one and in for this one. Current is always in something. Change in voltage is always across something. And finally, with our short circuit, what you get with this one is explosions. And that's basically just because there's no loss of energy. So what happens is the electrons can flow through, and the only thing they're going to do is heat up because they can travel so quickly. Friction in the wire is going to make them heat up, and then eventually they overheat. So you don't want short circuits. So let's take a look at what these guys look like when we put them in circuit diagrams, and how do we solve for each component of the circuit. So first up, in a series, just like we had before, I'll make a little circuit here. R1, R2, R3, there's my battery on the left. Parallel, just like we drew it before. R1, R2, D2. Just kidding, R3. There we go. So that's what they look like. Now, how do we find the total resistance? Now, in series, the current, it has to flow through every single one of the resistors, meaning that each one you go through is just going to add on to the last one. Because remember, resistance is how much hindrance the electrons are going to feel as they flow through it. So they have to go through all three of these. And you can kind of think of that like if we're still using the hose analogy, it's sections where the hose gets really tiny that's slowing down the flow. So for every section it goes through, that's going to slow it down some more. So our R total is going to be equal to just straight adding up our resistors. And if there's more, we just continue to add them on. Whereas in this one, now there are multiple different pathways. If you think about people walking down a hallway, if there's only one hallway and it's cram-packed with people, they're not really going to be able to move. But if you give them three different ways, that's going to decrease the amount of resistance they're feeling to moving forward. You can spread out. There's not as much friction. So in these cases, what you get is an inverse. You add the inverse of each of your resistors. So sum of your resistors, sum of the inverse of your resistors, and then you take the inverse of that. And you can do that for as many branches as you want. Now, to find the total current, and this is actually going to be true for both of them, all you do to find I tote, V equals IR, so now V tote, so that's going to be the amount in your battery divided by your total resistance. You get total resistance from these, so it's just a slightly different way, but you still solve for I tote the same either way. Now, how do you find the current in each resistors? Well, like we said before, in this one, current is exactly the same in all of them. So what we do is we just say I tote is equal to, or sorry, the I in an individual resistor is exactly the same as I tote. So it's the same for every single resistor. Now when we come over to parallel, the resistor that has the most resistance is probably going to have the least amount of electrons that flow through it. Think about it in the pipe analogy. Smaller pipe, not as much water can flow through. Biggest pipe, lowest resistance, is going to have the most. So in this one, what we do is we have to solve for it just like we would on any of the other ones. We'd solve I equals V over R. Now each one of these is going to have the same V. So you're just going to take V divided by the R. But your total is just going to be the sum of your currents, because as it flows through each one, they're all going to have, they're all going to have to add up to the total, because electrons flow in here, they split up and go through all of them. So together they should add back up to the initial amount that came through. Now, how do we find the voltage of the total voltage in a system? Well, it's going to be the same way for both of them. V tote, normally it'll just be your battery, but V tote is going to be, let's see, I tote times R tote. Just rearranging that. Now, let's find the voltage. Hold on. Oh, one more thing we can do with that is that, and I'll break it up a little. So this guy goes on both of them. But for finding your total voltage on this side, your resistor's voltages are going to have to add up, because we come out of the battery with some amount of potential difference. Every single time that we go through one, we drop by some amount. Meaning that in this case, V tote equals V1 plus V2 plus V3. Remember, that's the voltage in each resistor. Whereas on this side, every single resistor, since it's one pathway to get to the battery, is going to have the exact same. So V tote equals V1 equals V2 equals V3. They're all going to be equal to the total. So you're noticing a parallel here. Current, they're all the same for series. Voltage, they're all the same for parallel. And finally, how do we find the voltage in any one given resistor? Well, it's the same idea for both of them. V, let's just say Vn for the number of some resistor, is equal to the current in that resistor times the resistance of that resistor. Now, for series circuits, your current is going to be the same for all of them. And you can use this to go backwards on a parallel circuit, where now you know the voltage in all of them is exactly the same, so you're just dividing it by the resistance of that resistor. But this is the main idea for looking at the circuit diagrams of parallel and series. Now we'll take a second and we will go over a problem with it.